Somewhere in the Norwegian Sea, a single school of mackerel is swimming just below the surface. It stretches wider than 2 football fields. It weighs more than some cargo ships. And in about 45 minutes, every single fish in that school will be inside the hold of one boat. This is industrial purse seine fishing. One net, one drop, hundreds of tons of mackerel pulled from the ocean in a single operation. But getting to that moment takes a level of skill, timing, and technology that most people never think about. Because if the crew gets it wrong, if the net tangles, if the school dives, if the timing is off by even a few minutes, they lose everything. So how do they actually do it? It starts long before the net hits the water. A mackerel purse seiner is not a small boat. The larger vessels operating out of Norway and Scotland run 60 to 70 meters long. The net alone, if you pulled it out of the water and laid it flat, would fill the back of a semi-truck. These nets can stretch over 700 meters in length and hang 200 meters deep, weighted at the bottom with several tons of zinc to make them sink fast. The whole setup costs around 250,000 pounds just for the net. That's before you count the boat, the electronics, the crew, or the fuel to get out there. The crew is usually small for the scale of what they're doing. You've got the skipper, a mate, deckhands, an engineer, and maybe a few more depending on the vessel. But the skipper is the one who matters most in the early hours, because before anything else happens, somebody has to find the fish. Mackerel don't have swim bladders. That's the air-filled organ most fish use to control their buoyancy. Without one, mackerel have to swim constantly just to keep from sinking. They can't stop. They can't hover. They're always moving, often near the surface, in schools that can range anywhere from a few tons to over 7,000 tons of biomass. And because they lack that swim bladder, they're actually harder to detect on traditional echo sounders than other pelagic fish like herring. So skippers rely on a combination of tools. Multi-beam sonar gives them a three-dimensional view of what's happening underwater. Echo sounders scan the water column beneath the hull. Radar picks up surface disturbances. And then there are the old-school signs that experienced captains still watch for. Flocks of diving seabirds, patches of rippled water that look different from the surrounding sea, a subtle color change on the surface where a dense school is pushing bait fish upward. When the skipper spots what looks like a good school, the real calculation begins. Mackerel swim fast, up to 35 miles per hour in short bursts. Schools move constantly, sometimes covering ground at 1.5 meters per second. The skipper has to estimate the school's size, its depth, its speed, its direction, and then decide whether the conditions are right to set the net. Because once the net goes in the water, there's no pulling it back. It's committed. This is where the skiff comes in. A smaller boat, launched off the stern of the main vessel, takes one end of the net and peels away. The seiner circles the school, while the skiff holds its end in place, and the net pays out behind the main vessel in a massive arc. The goal is to complete the circle before the school realizes what's happening and scatters. If the mackerel sense the vessel's approach and bolt, the whole set is wasted. Hundreds of meters of net in the water, hours of work, fuel burned, and nothing to show for it. But if the circle closes, the next step is pursing. A heavy cable, called the purse line, runs through metal rings along the bottom edge of the net. The crew winches the cable in, and the bottom of the net draws shut like a drawstring bag. That's where the name comes from, purse seine, like closing a purse. Now the school is trapped. Hundreds of tons of mackerel in a shrinking bowl of netting pressed against the side of the vessel. The fish are still alive, still swimming, packed tighter and tighter as the crew hauls the net aboard using hydraulic power blocks. These are heavy-duty mechanical pulleys that were introduced in the 1950s, and they completely changed commercial fishing. Before power blocks, crews hauled nets by hand. The UN's Food and Agriculture Organization has said that no single invention contributed more to the effectiveness of purse seining. As the net comes in, the usable space gets smaller and smaller until all the fish are concentrated in a reinforced section called the bunt. This is the strongest part of the net, built to handle the combined weight of the catch. And this is where the operation shifts from hunting to logistics. For mackerel and other small pelagic species, modern vessels don't scoop the fish out with a braille net anymore. They pump them. Industrial fish pumps suck the mackerel directly from the bunt through a water separator that drains the seawater back overboard and into refrigerated seawater tanks below deck. These RSW tanks keep the catch chilled to preserve quality because mackerel is an oily fish. It spoils fast. The difference between a premium catch and a worthless one can come down to how quickly the fish get cooled after they leave the water. If you're watching this and thinking about the scale of it, consider this. In a single week in 2023, Norwegian purse seiners landed over 22,000 tons of mackerel in the Norwegian Sea. 130 vessels, 1 week. The fish were averaging over 500 grams each, which fishermen described as unusually large. Industry figures in Norway called it a pure rock concert in the Norwegian Sea. We dig into stories like this every week. If that sounds good, subscribe. But here's where the story gets more complicated, because catching mackerel at this scale isn't just a technical achievement, it's become one of the most contentious fisheries disputes in the North Atlantic. For years, the mackerel stock in the Northeast Atlantic was considered well managed. Countries like the UK, Norway, and Ireland fished within limits certified as sustainable. But then, mackerel started showing up in new waters. As ocean temperatures shifted, the fish migrated further north and west into Icelandic and Faroes waters. Those countries, whose expensive pelagic fleets had been fishing blue whiting until those stocks declined, saw an opportunity. Iceland increased its self-set mackerel quota from around 2,000 tons in the mid-2000s to 130,000 tons by 2010. The Faroe Islands jumped from 25,000 to 150,000 tons. The result was chaos. Norway blockaded its ports to Icelandic and Faroes vessels. Scottish trawlers physically blocked a Faroes boat carrying 1,100 tons of mackerel from entering Peterhead Harbor. The mackerel lost its Marine Stewardship Council sustainability certification in 2012 because total catches were on track to exceed 900,000 tons, at least 260,000 tons, over what scientists recommended, and the dispute never really got resolved. Fast forward to late 2025, and scientists recommended a total catch of no more than about 174,000 tons for 2026. The UK, Norway, the Faroe Islands, and Iceland agreed on a quota of 299,000 tons instead. When you add in what Russia catches separately, total fishing pressure could push past 400,000 tons, more than double what scientists say the stock can handle. So every time one of those 70-meter seiners drops a net around a school of mackerel, it's happening inside a much bigger story. A story about who owns migrating fish in a warming ocean. about whether the nations catching them can agree on how many are too many, about whether the technology that makes 500-ton catches possible is the same technology that could collapse the fishery entirely. The mackerel don't care about any of this, obviously. They just keep swimming because they have to. Without a swim bladder, stopping isn't an option. They move through the water in schools so dense that sonar operators can track them from the surface, following plankton blooms and ocean currents the same way their ancestors have for millions of years. The fishermen who chase them will tell you it's still a gamble. The sonar can show you a school, but it can't guarantee the net will close in time. The weather can turn, the fish can dive, equipment breaks, and even when everything goes right, there's the question of whether the fish will still be there next season and the season after that. That's the tension at the heart of this entire industry. The better the technology gets, the more fish you can catch, and the more fish you catch, the harder it becomes to make sure there are enough left. There's another one on screen if you're not done yet.